So I chose to do my topic on congenital prosopagnosia. It took me a while to figure out how to say that. Congenital prosopagnosia, or CP, which is what I'm going to call it from now on for this presentation, is also called face blindness. CP is a hereditary neurological dysfunction where a person struggles to recognize faces of loved ones, coworkers, or famous people, as well as their facial cues or expressions. CP is often presented at an early age, more likely to be the proper diagnosis in the absence of a previous brain injury or developmental disorder. Individuals with CP often focus their gaze on a person's hair, nose, or ears, but neglect the eyes, whereas those without CP innately focus our gaze on the eyes of the other person and then examine other parts. Individuals with CP can also forget the faces of those that they do not see for an extended period of time. Today's study is going to focus on the article titled First the Nose, Last the Eyes in Congenital Prosopagnosia. Look like your father looks. The purpose of this study was to describe the characteristics of eye movement (EM) patterns in familial subjects with similar struggles that are faced on a daily basis when interacting with others. Due to the lack of available unfamiliar stimuli that can be used within a CP study, Lucas and associates strive to add supplemental research to the limitations of eye movement studies for family members diagnosed with CP. There were two tasks for each participant to complete. One, verbally name each person based on a complete facial image and also a cropped facial image, which was simply having the participant or stimuli place a headband on their head. Two, decide whether or not the image provided that was black and white was of an older person or a younger person, or which one was male or female. Like any other experiment, participants were separated into groups, experimental and control. The experimental group consisted of a father and son duo. The father was 38 years old and the son was 6 years old, and they were both diagnosed with CP, while the control group did not have CP and consisted of a 39-year-old and a 6-year-old boy that had no relation. The individuals chosen to be the stimuli in this example were based on the frequency of encounters with each member, while unfamiliar stimuli was based on the age and gender of that person's relatives. For example, with the complete images, 6 pictures were given to both RG and LG, 6 pictures that included their self, the wife or the mother, their grandparents, and their aunt. Uh, and these images would be considered the personal familial stimuli or familiar stimuli. They were also shown pictures of strangers, which were matched with the relative's sex and age, and that's considered the unfamiliar stimuli. For them to complete task 2, they were shown 12 pictures to make a age decision and 12 pictures for a gender decision. Of these 12 images, 6 of them were for the age, 6 of them were young, 6 of them were older. For the gender, 6 were male, 6 were female. And for the control group, they were shown the same type of images for the familiar stimuli and the same type of images for the unfamiliar stimuli. Experimenters utilized an eye tracking system to measure where the participant's gaze was fixated, how many points of fixation were there, and how long did the fixation last. A microphone was used to record the verbal responses to the images that remained on the screen until a name was given or the statement, "I don't know," was made. No indications were given to the participants on whether they answered correctly or not. Between each image, the participant was instructed to focus on a cross that was displayed outside of the image in order to limit overexposure to eye movement patterns. According to the results displayed in the article, the eyes, nose, and mouth were the target fixations being measured. In Graph A, you can see that the majority of the fixations for the experimental group occurred on the nose and the mouth, while less than 30% of the time was focused on the eyes. For the control group, the eyes were the main point of fixation. In Graph B, you can see that the complete faces yielded a similar ratio to the Graph A. During the age and gender task, the results varied among all participants. In Graph C, the control group and LG, the child, focused on the eyes and responded with male or female, while RG focused primarily on the nose. In Graph D, it was varied highly with the control child, looking at all three attributes almost equally, and the control adult focusing primarily on the eyes and hardly any on the mouth. As for LG, he surprisingly focused on the eyes more, while his father looked to have almost looked at each attribute equally, but swaying more towards the mouth. There was not a lot of variance of when it came to the accuracy of the age and gender among both groups, but when it came to the facial recognition, LG, the child, failed for both the cropped and the complete faces, whereas RG, the adult, failed the cropped face portion but passed the complete faces. To wrap up this article, it concluded that the findings are consistent with the literature that's already been published. There are still limited studies that examine the eye movement patterns during facial recognition in relation to individuals diagnosed with CP. The explicit verbal responses, where the EM was used until a response was given, it did not increase the number of fixation, but it did show a longer duration in fixation between images and responses. More studies are still needed to better understand those diagnosed with CP. Thank you. That's all I have today.